The fastest wind speed ever measured on Earth didn't come from a hurricane. It came from a tornado, spinning past 300 miles an hour. That number came from a radar reading during a storm in Oklahoma in 1999, and it still stands as the fastest wind ever recorded on the planet. A tornado that strong can strip asphalt clean off a highway, peel the bark off a tree in seconds, and drive a piece of straw straight through a wooden fence post, like a nail. These storms only last minutes, sometimes only seconds, yet they carry more raw power per square foot than almost anything else in nature. An average tornado stays on the ground for about 10 minutes and travels only a few miles. But the biggest ones can carve a path over a mile wide, stay on the ground for hours, and travel more than 100 miles before finally lifting. Long before radar or satellites, people had no real way to explain a rotating column of wind that could erase a farm in seconds. Ancient cultures blamed tornadoes on angry gods, restless spirits, or divine punishment, and storms were treated as warnings rather than weather. Communities across the American plains dug root cellars and storm pits into the ground. The only real defense anyone had for generations before modern forecasting existed. Early scientists guessed that tornadoes formed from clashing winds, but without instruments to measure what was actually happening inside a storm. Most of that thinking amounted to educated guessing dressed up as science. It took until the 20th century for meteorologists to even agree that tornado forecasting was possible at all. And the first official tornado forecast in the United States wasn't issued until 1948, a moment that changed how the country prepared for severe weather going forward. Today, a tornado is defined with real precision, a violently rotating column of air that stretches from a thunderstorm cloud down to the ground below. Most tornadoes form from a specific kind of storm called a supercell, a thunderstorm built around a deep, persistent, rotating updraft. Modern Doppler radar can spot that rotation building inside a storm before a funnel ever touches down, giving forecasters minutes, sometimes tens of minutes, to issue a warning to the public. The National Weather Service tracks every reported tornado across the country and ranks its damage using the Enhanced Fujita scale, running from EF0 for minor damage up to EF5 for total, catastrophic destruction. That is the same category of violent rotation capable of producing wind speeds over 300 miles an hour, strong enough to flatten almost anything standing in its way. That single ranking system turned tornado science from rough guesswork into a structured, data-driven field, one that keeps improving as radar technology gets sharper every year. Inside a supercell, the parts fit together like a machine built purely out of moving air. A wall cloud drops beneath the base of the storm, marking the spot where rotation is tightening and dropping lower. Above it sits the mesocyclone, a broad rotating column of air that acts as the engine driving the entire system. When conditions align just right, a narrower funnel cloud stretches down from that wall cloud, and once the funnel makes contact with the ground, it officially becomes a tornado, rather than just a rotating cloud. Around the base, a debris cloud of dirt and wreckage often forms before the funnel itself is even visible, which is why trained spotters are taught to watch the ground as closely as they watch the sky. Some of the strongest tornadoes even split apart into multiple smaller vortices, spinning satellite funnels that circle the main one and add extra bursts of destructive wind on top of an already violent storm. The physics behind that rotation comes down to wind shear, a change in wind speed or direction at different heights in the atmosphere above the ground. When fast winds high in the atmosphere blow one direction, while slower winds near the ground blow another, the air caught between them starts to roll, much like a rolling pin lying on its side. A powerful updraft inside the storm can tilt that rolling motion upright, turning horizontal spin into a tight vertical one. That vertical spin becomes the mesocyclone, and as it tightens, the spin speeds up for the same reason a spinning skater speeds up, by pulling their arms in close to their body. Unlike hurricanes, tornadoes don't rely on the Coriolis effect to spin at all. Their rotation comes entirely from local wind shear and the storm's own updraft, which is part of why they can form so fast and why predicting the exact moment one touches ground remains one of the hardest open problems in meteorology today. For anyone who has stood in a tornado's path, the memory usually isn't visual first, it's the sound. Survivors consistently describe it as a freight train roar, a deep, grinding rumble that arrives before the funnel itself is even visible through the rain and dust. That sound alone triggers a raw kind of fear that has shaped how entire regions behave every single spring. It is a strange thing to fear and chase at the same time. But that same 300-mile-an-hour wind is exactly what pulls a small but devoted group of storm chasers toward the storm instead of away from it, driving them thousands of miles a season for a chance to witness one up close and document it. That mix of terror and fascination is part of why tornado footage draws so much attention online every year, and why tornado season quietly turns into appointment viewing for weather watchers across the entire country. In the middle of the United States, across a stretch of land known as Tornado Alley, tornado season shapes daily life in ways outsiders rarely notice. Schools run tornado drills the same way coastal schools run hurricane drills, practicing the routine until it becomes automatic. Many homes and businesses across the region are built with dedicated storm shelters or reinforced safe rooms, and outdoor warning sirens are tested on a set schedule, so residents recognize the sound instantly the moment it actually matters. Local news stations interrupt regular programming the second a warning is issued, and entire communities have developed rituals around watching the sky change color and texture before a storm rolls in. That shared vigilance has become part of regional identity, something people who grow up there carry with them long after they move away to somewhere calmer, and something newcomers to the region have to learn fast. The United States sees more tornadoes than any other country on Earth, with more than 1,000 reported in a typical year, far ahead of any other nation on record. That volume has built an entire economic ecosystem around tornado risk, specialized home insurance markets, storm shelter manufacturers, and a construction industry that increasingly designs for wind resistance across tornado-prone regions. Rebuilding after a major outbreak can cost communities billions of dollars in a single season, and insurers price that risk into premiums across a whole region, not just the towns that happen to get hit directly. Tornado tourism has even grown into its own small industry, with guided chasing tours selling seats to travelers who want a first-hand look at severe weather from a safe distance, turning a genuine hazard into a bucket list experience for thousands of people every spring. Tornadoes remain one of the few forces on Earth that can level a well-built structure in under a minute. And after more than a century of serious study, science still can't say exactly when or where the next one will drop. That mix of raw power and stubborn unpredictability, a wind speed once measured past 300 miles an hour, is exactly what keeps tornadoes at the center of both meteorology and imagination, season after season. Scribology breaks down the science behind the wildest things every week. Subscribe, catch the full weather playlist, and drop the next disaster to cover below. Tornadoes prove nature doesn't need a coastline to unleash the fastest winds on the planet.